Very well. What we learned so far, we start talking about hypothesis testing for the mean. Remember, we start talking about different types of hypotheses. And it was a summary that I asked you to write on a piece of paper and use it as a reference when you're dealing with hypothesis testing. Hypothesis testing for population mean, and the other one is hypothesis testing for population proportion. In previous session, we talked about hypothesis testing for population mean, mu. We had 3 scenarios. In each question related to hypothesis testing for population mean, you either work with the first scenario, or it is the second scenario, or it is the third scenario. And remember that we used our calculator to make sure we find the correct p-value. Well, we have another situation that you might end up seeing in different statistical analysis questions. Hypothesis test for paired samples. What is a paired samples? Introduction. In previous lesson, we tested claims about a population mean. In this lesson, we learn how to test a claim about a population mean of paired differences. So our focus is on paired samples. We will see that the process of testing claims about a population mean of paired differences is the same as the process for testing claims about a population mean. Very well. Assessing a psychological treatment. Psychologists often argue over the best way to help people with anxiety. There are 2 possible treatments. 2 possible treatments. One of them is counseling sessions, and the other one is pharmaceutical treatments. In other words, medicine that helps to reduce anxiety. Suppose that a team of psychologists has recommended that people who experience anxiety attacks should receive regular counseling. The psychologists claim that keyword. The counseling sessions provide a therapeutic or healing experience. The psychologists promote this type of therapy rather than pharmaceutical treatments. Okay, there are 2 types of treatments. You're the statistician and you would like to know which one is more effective. Okay, to test the effectiveness of counseling, a researcher randomly selects 6 people. How many people? 6 people. So we have a group of 6 people who experience anxiety attacks. These 6 people are interested in the counseling treatment. So the first treatment, counseling treatment. The researcher gives each person an anxiety test before and after the person has a counseling session with a therapist. Higher scores on the test indicate a higher level of anxiety in the person taking the test. Very well. Okay. You're the statistician. This is the first treatment. It's counseling and You are collecting data, pre-counseling, and also post-counseling score. You're interested in knowing that if counseling sessions reduce anxiety or not. So we need some measurements before and some other measurements after the treatment. The test scores of 6 people are shown in the table below. At 5% level of significance, important information, so let us highlight this, 5% level of significance, can we confirm that the counseling sessions reduce anxiety? So you're the statistician, you're given this information, and the person asks you, hey, can I conclude that this is my research paper, these are the data that I have, I'm going to present this in a conference, I need your help. At 5% level of significance, can I confirm that counseling sessions reduce anxiety? Assume the population of test score differences is normally distributed. So first of all, the very first question that you need to answer is, are the data paired? Explain why you think they are paired or not. Well, remember that we say that a set of data is paired if you have the same group of people, with 2 treatments. The first treatment, same people, same sample, same group of people with 2 treatments. Treatment 1 and treatment 2. So the answer is yes, we have the same group of people with 2 treatments, pre-counseling and then post-counseling. We're measuring the scores for the same group of people. Okay, perfect. Our next step is to construct the null hypothesis, alternative hypothesis, then decide at 5% level of significance, we reject or fail to reject the null hypothesis. This is our information. Now we're going to start constructing null and alternative hypothesis for this collection of data. If counseling does not make a difference in anxiety levels, what should the mean of the differences in the test scores be? Again, if counseling doesn't make a difference in anxiety level, what should the mean of the differences in test scores be? It means that previous and post scores are the same. So if it doesn't make any difference, it means that the scores must be the same. So it must be 0. So the mean must be 0. If there is no difference between the pre-counseling score and post-counseling score, it means that it is 0. There is no difference between them. If counseling helps reduce anxiety and does make a difference, would we expect the difference to be positive or negative? Well, okay. Remember that the higher score shows more anxiety. So if pre-counseling has a score and post-counseling has another score for the same person, if it is effective, it means that the person experienced higher score for anxiety before counseling. So it means that the pre-score must be larger than the post-score. So if counseling helps reduce anxiety and does make a difference, would we expect the difference to be positive or negative? So post-counseling minus pre-counseling, this number is smaller than this number. For example, suppose you have 66 and 64. The anxiety score is reduced. So 64 minus 66 is going to be -2. You can always use an example to see and check the sign. So you have -2, so it's going to be negative. State the null and alternative hypotheses. Well, okay. We're going to claim that it is effective. The claim is the counseling is effective. What's the meaning of that? It means that it reduces anxiety. It means that the difference is negative. The mean is negative. The mean is less than 0. This is our claim. Claim is counseling is effective. It means that it reduces the level of anxiety. It means that the mean is going to be negative. The mean is negative. So again, let us get back to what we constructed before. Which scenario is this? Is this the first scenario? Is this the second scenario? Or is this the third scenario? It says less than 0. Less than. So this is the first scenario. It means that we have a left-tailed graph. Our alternative hypothesis in this question is given to us. Alternative hypothesis, which says mean is less than 0. And the null hypothesis, even though null hypothesis is not given, we can quickly construct the null hypothesis because null hypothesis is the opposite of alternative hypothesis. Mean is larger than or equal to 0. As you know, the tail of the graph depends on the alternative hypothesis, and this is a left-tailed graph. Left-tailed graph. Okay, left-tailed graph. It means that this is your rejection region on the left-hand side. Are the criteria for approximate normality met? Yes, of course, because in the question it says, hey, suppose it's normally distributed. Well, so remember that we formed our null and alternative hypothesis. Now we're interested in finding the standardized test statistic. We want to know what is T. T is equal to X sub 1 bar, the mean of the first sample, minus the mean of the second sample, minus the difference between the population means divided by square root of S sub 1 squared divided by N1 plus S sub 2 squared divided by N2. We're going to calculate our T, and eventually we're going to use our calculator to make these calculations. Let's take a look at the data that we have. In our data, pre-scores and post-scores are given. So let us enter all of this information here in our calculator to find the mean of the first one, the standard deviation of the first one, and the mean and standard deviation of the second set. Okay. Let's put this one here. Let's turn on the calculator. So let me just reset my calculator. I used it. Reset the defaults. Okay, let us go to stat, edit, in L1. Okay, so I have 66, I have 71, I have 80, 78, 85, and 90. And I'm going to go to L2 and enter information about post scores. So 64, then I have 65, 79, 81, another 81, and 91. Okay. Let us go to stat and go to calc, one variable, L1. Okay, so for the first set, X1 bar, or the mean of the first sample, is 78.33. And I'm going to go down inside the radical. S sub 1 is 8.82. Remember, it must be squared, divided by N1. N1 is the sample size. We have 6 people in the first sample. Now we go to stat, we go to calc, one variable. Now I need to change L1 into L2 because the rest of the information are entered in L2. So second 2 gives me L2. Let us do the calculation. It is 76.83 divided by S is 10.44. 10.44 squared divided by 6. Okay, this is my T. Remember that the level of significance is 5%. Let us go to stat. Let us go to tests. We have 2 sample t-test. 2 sample t-test. We have the data, and we're going to use the data that we entered in L1 and L2. Very well. So the alternative hypothesis says mu1 is less than mu2, or is it larger than mu2? So we're going to select the second one, which is related to inequality. Here we go. So larger than mu2. Okay. And let us do the calculation. So as you can see, your t is 0.26. The p-value is 0.39. It's almost 40. This is my t. 0.27. And the p-value is approximately 0.40. Now, do we reject or we fail to reject the null hypothesis? This is our p-value, almost. So take a look at your p-value. It's almost 40%. This is larger than the 5% of level of significance, which is given in the question to us. So what's the meaning of that? Since p-value is larger than level of significance, we fail to reject the null hypothesis. We fail to reject the null hypothesis. What was the null hypothesis? The null hypothesis was mu, the mean, is larger than or equal to 0. What's the meaning of that? It means that we fail to reject it. It means that at 5% level of significance, there is not enough evidence to conclude that the mean difference is larger than or equal to 0. It means that this evidence that we have doesn't allow us to conclude that the average anxiety level are lower after counseling sessions. So at 5% level of significance, we cannot support that counseling is helpful. You might say, okay, now I'm going to collect more data, more information. Since it's just 6, I'm going to examine more people and rerun the test again. Very well. So let us start part 3. We're going to talk about hypothesis testing, and then we're going to construct confidence interval for difference in 2 population proportions. So far we talked about population mean and how to analyze population mean. We're done with that. Now we're going to work with the difference in 2 population proportions. Introduction. In this lesson, we will explore how differences in a sample proportions can be used to estimate the difference in population proportions. Again, remember that we have populations. Those are large data sets. We don't have enough time, enough money, enough people to gather information in these two populations. So what we do instead, we just take random samples from these two populations, make assumptions about those information taken from these two populations, and then we say, well, since those informations are coming from these two populations, it's safe to say it satisfies for those two populations as well. Okay. In the two dot plots below, each dot represents a random sample of adults from either the millennial or baby boomer generation. We're going to use specific differences in sample proportions of two populations who used Facebook for political news. They collected the data for us, and these are the dot plots that we have from those two population samples. The location of the dot on the x-axis shows the proportion of millennials or baby boomers in that particular sample who relied on Facebook for political news. 100 different samples of size 65 from the millennial population were randomly generated. Similarly, 100 different samples of size 50 were generated from baby boomer population. So from the first population, we took 100 samples. Sample 1, sample 2, sample 3, sample 4, sample 5, 100 samples. Each sample has size 50. From the second population, 100 samples of size 50. So we continue this process 100 times. And these are the information that we have. Each dot represents the proportion. The first dot plot, the second dot plot. Take a look at the numbers on horizontal axis. These are in decimal, or if you convert them into percentage, you have 20%, 30%, 40%, 50%, 60%, 70%, 80%. So for millennials, as you can see, the data are highly located on the right-hand side. So if you want to investigate the mean or typical value, you say, hey, the typical value is around 60% here. This is the data, the center, the typical value, the balancing point is about 60% here. However, for baby boomers, it is highly located on the left-hand side. So it seems like the center is around 35%. Remember that we are collecting the data and we're interested in knowing the proportion of people who rely on Facebook for political news. What is the proportion? The proportion who rely on Facebook for political news for millennials seems to be around 60%, which is huge. And the proportion of baby boomers who rely on Facebook for political news is around 35%. Okay, you have two populations and we took samples from those populations. And these are the visualization. Remember that as a statistician, after collecting the data, we're interested in visualizing the data. It helps us to understand the behavior of the data. Okay, what is the next step? You're the statistician. Just looking at the data is not enough for you. You cannot go to a conference and say that, hey, I collected the data and these are the shape of the data. So based on the shape, I'm going to make assumptions and make conclusions about populations. We need numbers. We need numerical characteristics to be able to form hypothesis testing, to construct the confidence interval. It's not enough. Okay, in our next step, we're going to make some calculations. What are the calculations? Well, through the discussion, approximate normality of sampling distribution is assumed. So we already know that we have a normal distribution and the normality is met. This means we assume that the underlying sampling distribution are roughly normal. So we're happy about that. We can move on to use formulas that we introduced for normal distribution. The assumptions require that n times p and n times 1 minus p are both at least 10 for both the populations of millennials and baby boomers. So based on the data that we have, we're interested in finding the sample proportion for the first and the second one. Compare these distributions of sample proportions in terms of center, shape, and spread. The center, we're going to pick a value that best represents each distribution for the dot plots above and one for the proportions of millennials, P sub M, and one for proportions of baby boomers, P sub B. So remember that when we're using hat, it means that we're referring to our samples. P sub M hat and P sub B hat. Well, by looking at the dot plot, you can say that the center is around 60%. So 60%. And the center is around 35%. These are just approximation. You might come up with a number which is close to these numbers, like 61%, 62%, 36%, 37%, and so on. These are just approximation. Shape. Examine the shapes of distributions. Do these distributions of values appear as if they may be drawn from a normal population? Well, take a look at each of these graphs. It seems to be normal, and the second one, it seems to be normal as well. So approximately these are normal by looking at the shapes. Look at both distributions and compare their spread. So let's take a look at these two distributions. The spread of millennials, it starts from this point and it stops here. The spread for baby boomers starts here and stops here. So it seems like the spread of millennials starts from, seems like 47%, and it stops at 74%. So this is the spread between these two. And the spread for baby boomers, it seems like it starts at, let's see, it's 20, 23, 24%, 23%, and it stops at 50, 52%, 53%. So if we find the difference between these two numbers, 74% minus 47%, 27, and here we have 52% minus 23%. So as you can see, the spread is almost the same, But the spread for baby boomers is a little bit higher than the spread for millennials. Just looking at the spread. Okay. In our next step, the dot plot below displays the distribution of all differences in proportions between millennials and baby boomers. So what did we do? We took the proportions and we start subtracting them. What is the difference between them? We're interested in constructing a new distribution using the differences between these two distributions. It ends up giving up this new distribution of proportions of differences. Proportion of millennials minus proportion of baby boomers. We're interested in understanding the behavior of the difference between these two samples. So the dot plot below displays the distribution of all differences in proportions between millennials and baby boomers. This dot plot combines the information from the two dot plots above. Each dot represents the value PM hat minus PB hat. So we take each proportion from these two samples and we start subtracting them. It gives us a new percentage, and these new percentage, they are represented by a dot, and we constructed new distribution. The value PM hat minus PB hat is the difference between proportions of millennials and baby boomers. Notice that the proportion of baby boomers is subtracted from the proportion of millennials. Very well. So this is our new distribution. As you can see, it's normal. It started from 0% to 50%, and it is normal. It helps us to analyze the information much better, much easier. Estimate the mean of the distribution of differences. So as you can see, the center on the horizontal axis is around 25%, maybe a little bit less. So we're going to approximate that by 25%. How does the mean of the distribution of differences compare to the representative values from the individual distributions of proportion in question 1A? Well, so when we have 25% as the center or representative for this new distribution, we can compare this number with the difference between these two means. So the mean of the millennials, it was around 60%, am I right? And this guy was almost 35%. So if we find the difference between them is around 60% minus 35%, which is, well, okay, 25%. We got a very close value to the center of this new distribution. It means that we are on the right track.